Hello, and welcome to page 62 in the workbook. We are looking at example 2, and this is going to be an opportunity to kind of tie together some of the concepts that we've been talking about up to this point. Okay, let's read this together. So the amount Q of the radioactive substance calcium 47, and I notice they don't give us units, so how about if we add units of grams here? So the amount of the radioactive substance in grams remaining is governed by the differential equation dq dt equals minus 0.15 q, where t represents elapsed time in days. Okay, so think of that differential equation as giving us some information about how fast the substance is decaying. That's the dq dt. And the first part of the problem would like us to show that the function q equals ce to the minus 0.15 t is a solution to the differential equation. Okay, well, we kind of know how this works. We've done a couple of problems like this. So to show that that's a solution, it's about demonstrating that this value of q makes our differential equation into a true statement. If we substitute that into the left and the right-hand side, we want to confirm that we get the same thing. Okay, so we'll start by just writing down what the left and the right-hand side of our differential equation is. So there's the left-hand side, dq dt, and the right-hand side looks like minus 0.15 q. Okay, and the idea is to get started by just substituting in the value of q to the left and the right, and here's the value of q, ce to the minus 0.15 t. Okay, so we'll do that in both places. And it's our job now just to do the calculations and see if we get the same thing for the left and the right-hand side. So let's start with the left side. It's asking us to take the derivative of this function, so we'll pull the c out, and then the derivative of e to the minus 0.15 t is just e to the minus 0.15 t times the derivative of the exponent, which is minus 0.15. And if we simplify that a bit, we get minus 0.15 c e to the minus 0.15 t. Okay, there's our left-hand side. Okay, what about the right-hand side? Well, here, there's no derivative to take. We just need to do multiplication. We're going to take minus 0.15 and multiply it by c e to the minus 0.15 t. Okay, and what do you think? Did we get the same thing on the left and the right side? We sure did. Okay, and the fact that we got the same expression on both sides confirms that c e to the minus 0.15 t is indeed a solution. Okay, and that's part A. So part B then asks us a type of question that I don't know that we've answered yet. This may very well be new. It would like us to solve the initial value problem, dq dt equals minus 0.15 q together with q of 0 equals 100. Okay, what do we mean when we say initial value problem? Okay, well, that's just a fancy term for a differential equation together with an initial condition. So it's just a differential equation with one extra piece of information. Okay, so the good news here is that we have already found a solution to the first part of this. Okay, actually it was given to us, but we confirmed that q equals c e to the minus 0.15 t is a solution to the differential equation. Okay, so we already know, okay, space is going to be a little bit limited here, so I'm going to try to write small, that a solution to the differential equation part of this just looks like that. Q equals c e to the minus 0.15 t. The one piece of information that's been added is this, that q of 0 is equal to 100. Okay, think of that as just an extra given piece of information. Okay, let's talk about what that means again. What is that statement saying? Well, 0 is a value of our input variable, which is time in our case, and then 100, that's a value of our output variable q. So it's like telling you that at time 0, we have 100 grams in our sample. That's our initial condition. Okay, well, what can we do with that? let's take a look here. So if we start with the given piece of information that we're given, and just think about algebraically what that's telling us, that's just saying if we substitute in t equals 0, then q has to be 100. So what we can do is go to the part of the solution that we already know and just substitute those two values in for q and t. Okay, so q is 100 and t is 0. So we know that that statement has to be true. And we do a little bit of algebra with that. This works out to 100 equals c e to that exponent over here is going to just turn into a 0. And e to the 0 is just 1. So what's interesting is that by doing the algebra, we figured out what the value of c has to be. C is 100. Okay, and so what we know then is that q equals 100. We just substitute the value of c in up here, is the solution to this initial value problem. We've actually completed the first part of the problem. They also asked us, though, to interpret this solution. What does that function mean? Okay, let me just finish this statement first. Okay, to the initial value problem. Okay, what does that really represent? Well, notice that this is a formula that you could use to substitute in values of t and get out values of q. So you can think of it as a formula for the amount of the radioactive substance after t, what's t measured in days? Okay, so if somebody said, I want to know how much radioactive substance is left after 20 days, you would just take 20, plug it in for t, and you could figure out exactly how much is left. Okay, so in words, let's try to describe that. Okay, solution gives a formula. Okay, after t days. Okay, so by giving you this initial condition, telling you how much of the substance we started with, that was enough information to boil it down to a single formula that's going to allow us to figure out how much of the substance is left after any time. Okay, so kind of thinking along those same lines, part C is asking us to do that essentially. Suppose that we start with 100 grams of a sample. That's the same assumption as what we made up here. How much of the sample will remain after 6 days? Okay, well, to answer that question, all we really need to do is to use the formula that we came up with, the answer to part B. Okay, we'll substitute in the appropriate time value and we will get out the amount that we want. So 100 e to the minus 0.15. 6 days is the value of t, so we will plug that in. Okay, let me try to write that a little bit more neatly. That's t. Okay, and this is a job for your calculator. You would go ahead and punch that in and discover that you get out 40.66, and our units should be grams. Okay, and that's our answer to C.